start. Hello, dear viewers. This is Sebato Joseph from Namugongo Secondary and Vocational School, and I'm here to discuss with you a topic in physics. That topic is pressure. Pressure. Some of you have heard about that word, pressure, in so many incidences. Like, for example, you have heard about when it is period for examinations and you're feeling some pressure. Of course, you've heard about maybe patients who are suffering from pressure. This is high blood pressure or low blood pressure. Another incident we can think about. Have you thought about any there? Okay. Yes. Yeah, think about pressure as gas pressure. Maybe you have a ball, you are inflating some gas, so you are applying some pressure. Talk about if you are squeezing something. For example, like you want to open a bottle of soda. Yes, you must apply some little pressure. Oh, please give me some pressure here. When you are at a car gas station and you want to fill your car tire, maybe you have got a flat tire, and now you need to inflate. So there is that pressure that you insert in the car tire. So that's what we want to discuss this time around. And as I told you, my name is Sebato Joseph, and we're going to begin with pressure in solids. Now, pressure can be in solids, and also pressure can be experienced in liquids. Today, we want to look at the definition of pressure. What is pressure? Have you ever heard about it? Can you try to define it there? Yes. We are going to look at the SI units, or the units of pressure. How do we measure pressure? Is it in kilograms? Is it in newtons? What's the unit of pressure? That's what we want to discuss today. Then we want to look at the formula for pressure in solids. How do we calculate pressure in solids? Then we also are going to discuss the maximum and minimum pressure. So we are going to define pressure as we are going to define pressure as the force acting normally per unit cross-sectional area of the surface. Pressure is the force acting normally excuse me. So we are saying that pressure can be obtained by getting the force acting divided by the area on which that force is applied. Now that word normally can stand for perpendicularly. Another word we can use is perpendicularly. So it should be at right angles. That force that is acting at right angles to a given surface, that is what we call pressure. So if you have a force, and you know in physics, force is a pull or a push on any object that can change the state of that object. That is a force. I know in Form 1 we talked about that one. Then area, of course, the space occupied by any object is the area. Then when you divide the force by the area, we can get what we call the pressure. And the force, you remember that the SI unit of force is a Newton. Then the SI unit of area is a square meter. That means the SI unit of pressure can be our SI unit of pressure is a Newton per square meter. We can write it like that. In some books, you'll find it like that. No problem. Newton per square meter. Or it can be a Pascal. or it can be a Pascal. Now, 1 Pascal or 1 Newton per square meter is equivalent to 1 Pascal. And they can ask you to define a Pascal. What is a Pascal? Now remember, this is an SI unit. And we are defining the SI unit of pressure. So if you are defining a Pascal, you make sure that the force that is being applied is 1 Newton and it is being applied on an area of 1 square meter. So when you divide that force of 1 Newton by the area of 1 square meter, you get what we call a Pascal. Get me right there? So pressure in solids, remember a solid is anything. Remember when we talk about the classification, we talk about solids, liquids, gases. So now we are concentrated on a solid. And remember, in some solids, we can be able to calculate their areas. And the pressure in a solid depends on 2 things. One, it depends on the force, the magnitude of the force applied. Remember, you are applying something. For example, if you step on a nail or on a needle, and it depends on the force. Someone who jumps there a little, step your foot on the nail, but you realize that where I'm stepping is a bit sharp. You remove your leg, you lift it earlier, without putting all your weight. That means the pain you're going to experience will not be the same as that of a person who has put all his weight on the nail. You get me right there? So when I talk about the magnitude of the force, I'm talking about the size of the force that you are applying on the object. So if someone, that's why when a car knocks a bicycle and the car is moving at a very high speed, there are very little chances for that person on that motorcycle, on the bicycle, to survive. Why? Because the big magnitude of force has been applied on that person. But if the car is moving very slowly and it knocks someone, of course you may get some injuries, but the chances of surviving are higher than when the car is moving at a very high speed. So the magnitude of the force applied determines the pressure on solid. Then number 2, we can talk about the cross-sectional area. The cross-sectional area, of course, you will see that sometimes the area on which a force is applied, cross-sectional area. So remember, we have said that pressure is force over area. There are 2 determinants here now. We have the force, the magnitude, and then we have the area on which the force is being applied. And you'll find that this one brings in so many things in application. When you are having an elephant, for example, some of you have gone to zoos and you have seen elephants. When you look at the hoof or the foot of the elephant, it's bigger. And when you look at the antelope, or let's say a goat, because some of you have seen goats, you are familiar with goats here. Now when you look at the hoof of a goat and one of an elephant, they are different, they are quite different. You see that the one for the elephant, because the elephant is big, of course it's very big, so its foot is large. And when you look at the one of the goat, it is small. Meaning that the area that is occupied by the foot of the elephant is different from the area that is occupied by the foot of a goat. Meaning that the elephant occupies the biggest area on the ground and the goat occupies a smaller area. And this is now taking us to what we call the minimum and maximum pressure in solids. So the area of contact is very, very crucial. Another instance can be, if you have a nail and you have a brick, and someone staples on a nail, and for you to staple on a brick, who feels more pain? Think about it. Who feels more pain? You will see that a person who steps on a nail feels more pain than a person who steps on a brick. Or maybe that's too big. Let me bring a nail and a pin. A nail and a small sharp pin. So a nail and a pin, they are two sharp instruments. But when you look at the cross-sectional area of a nail, the nail is bigger. And the one of a pin is smaller. So one of the two, one has a minimum area and one has got a maximum area. Don't get me very well here. There are two objects. One has got a bigger area, one has got a smaller area. Now, suppose you are the same person. Maybe you're unfortunate, and that day you're moving, maybe you didn't see very well, and you step first on a nail. You're the same person. You step on a nail, that means the force is the same. Suppose you're applying the same force or the same weight. So you step on the nail first. So we have a nail, and we have a small pin. Now this pin, of course, this nail is the you can say, big area. And our pin has got a small area. Now if I ask you, my viewer, which one gives more pain? Which one? Where do you feel more pain? Is it the nail or is it the pin? Yes. Good. You have seen that the pin, because it has a very small area, you feel more pain. Whereas the nail, you may feel pain, but not as much as the other one. Actually, if you have donated blood, may have donated, I think, like 5 times. I've been donating blood. Those people who collect blood from our body, when you look at their needles, they have a large opening. The area here is bigger compared to that of the other smaller needles in these other clinics, if you take note. And you find that if you are donating blood, the moment they plug that needle into your vein, you do not feel more pain compared to the other time when you're in a clinic, that smaller one. Meaning that if the area is big, the pressure becomes minimum. And if the area is small, the pressure becomes maximum. That is why, if you are to write the formula for minimum and maximum pressure, as you see there, the pressure increases when the area of contact decreases, and at the same time, the area decreases, the pressure decreases when the area increases. So what I was trying to say, that you to get pressure maximum pressure can be obtained by the force divided by minimum area. So for us to get a very big pressure, the area must be small. That explains why the elephant can move in a muddy ground very well, but a goat will find problems, will find it difficult to travel through that area which is muddy. Similarly, if you look at tractors, which always cultivate in wetlands, they have big hind tires. The tractors, they have what called big hind tires. I think you've ever seen them, those tractors. They have very big tires behind there. It's not for design. It's from pressure. Because those tires are big enough and they will exert little pressure on the ground. So the edge of contact will be bigger, it will be widened. And you find that the tractor can easily move in a muddy ground and it can cultivate very well. Whereas if it's a small car with very small tires, the pressure exerted by this car on the ground is going to be too much. And we find that this car will not be able to move in the muddy ground. The minimum pressure, we can abbreviate as pressure min, is obtained by the force or the weight divided by the maximum area. So, in case you want the pressure to be small, the area must be big. And in case I want the pressure to be very big, here you find that the area must be minimum. So it's vice versa. So this explains so many things in our daily lives. You'll find that even footballers, they have those shoes. This time now is for World Cup, of course. I believe you are watching World Cup. But if you critically look at the shoes of these players, they have those we can call them spikes. Lack of a better word, we can call them spikes. Spikes on football shoes. Because my diagrams, I'm not a very good artist here, but you'll find that on these shoes here, they are like spikes. You can call them spikes. Why do we have those spikes there? Why do we have? Think about it. Think about why do we have spikes on football shoes? Yes, you can ask your brother if he's a footballer. You can ask yourself if you play football. Why? It's not by design. It is for this player to exert maximum pressure on the ground. Because these spikes, they are small. So, if they are small, they exert minimum area on the ground. And you'll find that the pressure exerted there will be maximum. Thank you so much for viewing our videos. Please don't forget to subscribe to our channel. Visit our website down there, sbsnamugongo.com, and watch more videos. I'm going to be back in